Good morning. Today I will introduce a paper. The title is Evaluation of Three-Dimensional Accelerometer to Monitor and Classify Behavior Patterns in Cattle. There are 5 main parts of this presentation: background, materials and method, result, discussion, and conclusion. First, let's see the background. First, why classify and monitoring cattle behaviors? According to the previous research in this area, behavior is one of the commonly used and sensitive indicators of animal welfare. And real-time behavior analysis could provide useful information for early disease detection, and it can provide opportunity of early intervention, and this can already also provide useful information for individual management. And why we use 3-axis accelerometer? Here is the principle of the 3-axis accelerometer. Use this device, you can get 3-dimensional accelerations. And a remote monitoring system is needed because evaluation of cattle behavior pattern is difficult to accomplish due to the animal's response to human interaction. And this way, 3-axis acceleration can provide a non-invasive and objective measurement for the behavior monitor. And this device already widely used in human activity monitoring. And turning to the next point, talk about the materials and method. First, animal management. 15 cattle averaging 204 kilograms were randomly located in 3 groups, 5 cattle per group, and all the cattle were housed in a rectangular dry lot. And this is the devices this research used. A 3-axis accelerometer called sensor GP1L, and the combination method is USB, and it can use for 40 days. And through this device, the behaviors of cattle can be recorded. And the next part is accelerometer data collection. You can see in the picture that the accelerometer was placed in a waterproof case, which was tied on the leg, and you can see on the first picture the the x-axis is perpendicular to the ground when the cattle was standing, and the picture under that, you can see the y-axis it was perpendicular to the ground when cattle was lying, and the data was summarized based on a user design report intervals called epoch. In this trial, the epoch length was 3, 5, and 10 seconds. And five kind of basic data we can got through the accelerometer. First, the 3-dimension average acceleration of x, y, z axis, and the vector magnetic average acceleration, and the vector magnitude max acceleration. And under this is the formula for the vector magnitude max acceleration, and the two additional variable is added to increase the decision tree robustness. And next come to the video analysis. And on the left is the cattle behavior in this research, including standing, lying, and walking. The content about this step is you see the top of the picture is the video stream of the cattle behavior, and the bottom of this picture is the acceleration data stream. And the content of this step is when behaviors happen in the video, then marking the starting and ending time of the behavior on acceleration data stream. After this step, we could get acceleration data of different behaviors data marker. And then come to the data analysis. The video and the acceleration combined data was used to generate classification tree for each epoch. And the data was divided into two parts. 70% data was used to classify training, and classification tree categorized data based on included variables and known outcome, as you know, as the video behavior. And the purpose of the tree is to reduce the uncertainty which associate with every predict outcome. And and in this way, the data will divided into multiple grouping of data points. And the last step is logistic regression. The logistic regression was used on test data to evaluate the difference of classification accuracy among different activity and epochs. And the last results. In the first picture, we can see the lying stand and the lying and standing activity shows a good agreement with the non-video behavior, but walking activity is significantly lower than the lying and standing. And in the second diagram, we can say that there were no significant difference between 3 and 5 epoch, but 10-second epoch is much lower. The agreement is much lower than 3 and 5 epochs. And the discussion of this research, first, dynamic activities exhibit more variation that may be related to the individual as well as intensity of the activities. And if the activity is shorter than the span of the sport, the result average data will result in smaller intensity rating. And the second is optimizing the epoch setting is important, and the 5-second approach provides an added accuracy and based on memory constraint of the current unit. Last conclusion. Three-dimensional accelerometer are highly discriminatory for static posture activities in cattle, and the 5-second reporting interval yield accurate classification of activities. And the further research is needed to determine the ability of behavioral measurements to predict animal wellness and wellness status. Thank you for your attention.
Any questions? just indicate the movement of cathode is only lying, standing, and walking.
Yeah.
But I think sometimes those can be run.
Run, yeah.
Run. Whatever to running cattle.
Actually, running is more difficult to monitor in this research because, as you see, the lying and the standing is the agreement is very high, but walking is much lower because the dynamic activity is harder to monitor. So in that way, running is more harder. So in this research is not mentioned in this research.
Okay, thank you very much. Do you have any question from students? Response is okay.
Thank you for your presentation. Let me see the picture of the accelerator attached on the.
This?
Yes. The machine. Will the machine make any impression on the movement? Like, for example, if the machine attached on the like this, the machine went compared to the normal situation. Any problem on the machine or the movement?
The accelerometer was placed in a box, a case, a waterproof case, and there are much protect things around it. Outside of the case to protect it. So.
Thank you.
Thank you.
Thank you for presentation. Answer is 1010.
110. This? Which one? Upside. This one? Okay. You want to see this picture? Which?
Yeah, right.
Right. The cattle? The picture? Right. Left? Left. You mean this picture? This picture just to show to make the movement. How to say? The movement is kind of video, but through this way, through the accelerometer, it will turn into it can be quantification, turn into numbers. I don't know, is that right? The method. No. How to say it? It turned the movement into the things that we can make movement in the video, transmit it into the accelerations, and we can use this kind of data to quantification and classification.
Okay, thank you very much. Okay.
And is it possible that the device reduce the movement of the cathode?
Oh, maybe I think because maybe it is 0.5 kilogram. So I think it must be some effect on the cattle, but actually the result is good, so I think it is okay.
Okay, thank you.
Can you tell me whether the accelerometer is put on the back leg or the front leg, and if is there any difference between putting on the front leg versus the back leg?
Oh yeah. Maybe on the back leg, this is on the back leg, and when it's standing, it's straight. But you see, when he is lying, it can't just tied to the ground. So I think it is how to say, the change is very big and easily to detect. I think in this way.
Well, when the cow is eating, is mostly a lot of activity is associated with eating grass.
Feeding?
And so the front leg also is going to be moving more than the back leg to bring the head down to the grass.
Maybe in this research, only these two, only lying and standing and working, just detects only these three movements. So I think so. He used back leg, I think.
Thank you.
Thank you very much.
Thank you for the presentation. I have one question. The accelerator is what accelerator records that direct only the position of the code or
Sorry, pardon.
what records?
Records. Records. You mean the data?
Yeah.
What kind of data?
Yeah, the position, it's record the code position.
No. You see, when why it can be detected, because when it's standing, you see the acceleration of x-axis is perpendicular to the ground, but when it's lying, the tangle is totally changed like this. So it is obviously, it is easy to detect.
Thank you.
Other question? Okay, thank you. So, do you have any question from NTU?
Thank you for your interesting presentation. I have three questions about your paper. First one, is this accelerometer itself too heavy or too uncomfortable for the cattle? So it will it change the cattle's behavior only by this accelerometer? And the second question is in the classification tree.
Yeah.
Can you explain more about the classification? Because only three activities like standing, lying, and walking. So is there any more activity and analysis in this classification tree?
Yeah.
And the third question is, sorry, thank you. Only two questions.
Okay. The first question is that the device is too heavy for the cattle?
Yes.
Actually, only the accelerometer is not very heavy, but there must be a battery to provide the power to the accelerometer, and the waterproof case is necessary too. So this all the things is necessary, and but actually the things outside the case is soft. I think maybe I don't know how cat will feel, but according to the results, it is okay. And the second question. Classification tree is actually this is how does it work is there is acceleration data stream and there is a video stream, and I mentioned before they are how to say we marking the starting and ending time of the behavior on the acceleration, and so in classification tree we just how to say judge the different behaviors, and when the entropy until the entropy becomes 0, and all the data will divide into multiple grouping, I think. Is that enough?
So, how many activity or how many classification in this study? Only 3?
Only 3.
But I see the 3 picture, there are many.
You mean this picture? It's just the example, sorry.
Oh, okay. Thank you.
More questions?
Thank you for your presentation. And I'm a little curious about after you had the dynamic activity and how it will be used on the management of the kettles.
Management. Oh, pardon, sorry.
After you have the dynamic activity, because you will know that the kettle is standing or lying, and how will it be used on the management of the kettles, in your opinion?
Okay. Actually, especially this kind of behavior just used as important indicators for animal welfare and especially lying. So after we got this data, we can got the time of each behavior per day, and in this way we can detect the disease or find some how to say to see if the cattle is normal. I think maybe.
Okay, thank you.
Thank you.
Yeah, no more questions from the team.
Okay, thank you very much.